about the contents of section 2.3. We're going to do this before we do sections 2.1 and 2.2 just because we think that it's a little bit more logical. We're going to be talking about solving formulas for different variables, and this wheel, that's used in electronics pertaining to Ohm's law and Watt's power formula, we're going to do this in class because it's quite an involved little problem, and for me to demonstrate it here is not going to be to your benefit, and I think it'll be a lot more meaningful if we do this together in class. So I'm going to go ahead and start with the second example, which is pertaining to an automotive cornering force equation. And what we're going to be doing is we're going to be not finding an answer to a problem, but we're going to go ahead and isolate a variable given a formula. And I'm going to, before I do example 2, I'm going to just kind of throw out something really simple. Let's say that we're looking at the formula for area of a rectangle. Area of a rectangle. And the formula for that is area is equal to length times width. And we can express it that way. We can write it with a big dot in the middle. Maybe that'll help kind of understand what's going on. And this formula is great if we're always going to find the area and always going to be given the length and the width, but that's not always the case. Sometimes we're going to be given the area and maybe the width, and we have to find the length, or be given the area and be given the length, and we have to find the width. So it'd be really cool if we could have a formula that we can just use right off for each of the 3. And the reason that we're going to have 3 is because there are 3 variables in this formula. So what we do is we start with the basic one, and we end up, let's isolate the length first. And when you are isolating a variable, you're basically going to take the formula and break it into pieces and move things around. So our job is to generate a formula such that we end up with length is equal to something. And this will give us a formula just for length. And then over here, we're going to end up with a formula that's going to be just for width. So width is equal to something. So in order to isolate the L, this guy's got to go. He's in the way. And we have to break this action that's going on here. And right now what's happening is the width and the length are being multiplied by each other. So in order to undo that, we have to do the opposite of what it's doing. So the opposite of multiplication is division. So what we're going to do is, okay, let me start it again over here, length times width. Remember, I'm after length. So in order to get rid of him, in order to break the multiplication, I'm going to divide, and I'm going to divide by W. So I'm going to divide by W. And the rule is for an equation, in order to keep it balanced, whatever you do to one side, you have to do to the other. It's like a teeter-totter that you want to keep balanced. So what I do over here, I'm going to do over here. And what happens is these 2 variables, these W's, they drop out. They actually reduce down to 1. W goes into W once, W goes into W once, and we end up with A over W is equal to, well, length times 1 is just length, and then length over 1 is just length. And what we normally do is when we're isolating a variable, we always write the variable on the left side just to make it look pretty and it's pleasing to the eye. So here's the formula then for length that we generated from the formula for area of a rectangle. Now basically when we go to find the formula for width, it's exactly the same thing. So again, I'm going to start with the original. This time I'm going for W. That means the length has got to go. In order to get rid of the length, I have to do the opposite of what he's doing here. So I'm going to be dividing by length here, dividing by length here. These guys reduce out, leaving me with area over length is equal to width. And again, I like the variable on the left. So I just kind of pick it up and flip it over. and width is equal to area divided by length. So that's our starting point. So basically what we're doing is you start with a formula, you look at what you want, and you start breaking things apart. Okay, so let's take a look at this one that we have in our example, automotive cornering force. So if we want to know if you're going around a corner and some kind of a vehicle, race car, and you want to know what kind of G's you're going to experience, let's say, here's the formula. And it's kind of interesting, I guess, what these different variables stand for. I'd happily have to look it up just to make sure, but F is for force, V I'm going to guess is for velocity, how fast you're going, and R is for radius. I'm going to guess that anyway. For our purposes right here, we're not plugging in any numbers anywhere. So I don't need a calculator. I don't even really need to know what these variables stand for. So, and the job here is to go for V. That's the fella I want. So I'm going to start by writing down this formula, and I'm not going to write on my good sheet because it's in color and it's pretty and ink's expensive, so I'm just going to write on this scrap paper and show you what's going on. So I always start with the formula, and you all know how I like you to copy down the formula first. Now again, this is the guy I'm going for. Well, the first thing that what I want to do is I'm going to get rid of this guy down here. And before we even go there, I want to make mention of something to you. This is that little mnemonic that we follow to follow the rules for order of operations, and we do it in that order. And you know how my feelings about this. I don't really like it, but it's good enough for our purposes right now. So when you're isolating variables, you're going to be doing things in reverse. Let's see what that looks like in reverse. SADMEP, SADMEP. That's kind of interesting. So if there's any subtraction or addition going on, we're going to address that first. If there's any division and multiplication going on, we'll do that. If there's any exponents, we'll do that. And then we basically save the parentheses for last. And the best way to learn these things, how to manipulate this, is through practice. Well, I don't have any subtraction or addition going on here, so good enough. So I'm going to look and see if there's any division and multiplication. And sure enough, there is. Right here, there's a division going on here, and there's multiplication going on down here. So what I'm going to do is I'm going to get rid of this denominator. I'm going to clear out that denominator. Nobody likes well, most people don't like fractions, and so I'm going to get rid of that fraction. So I'm going to undo what's being done between the numerator and the denominator, which is division. And the way I do that, the opposite of division is multiplication. So what I'm going to do is I'm going to take my beginning formula, and I'm going to multiply this side by 32r, and I'm going to make it look like a fraction just because it's easier to digest. Fraction times a fraction. And oh, by the way, what I do to one side, I have to do to the other side. Now in this particular case, it doesn't matter that I put the 32r over on the left of the f. I could put it on the right of the f, but multiplication doesn't matter. A times b is the same thing as b times a, so I'm safe. So, and I didn't write it as a fraction over here. Well, why? Because this guy isn't a fraction. Good enough. So these guys actually, they drop out. They reduce down to 1, leaving me with just v squared, because I got a 1 and a 1 and a 1. And over here, I got these two guys together, and I'm just going to smush them together. 32r times f, so I'm going to write 32rf. Okay, so remember now, I'm after v. I want my very bottom line to end up saying v equals some answer. Well, so far I've got v squared. So I'm almost there. So that means that this exponent's got to go. And if you think about the PEMDAS, he's down here, so he's got to come next. I got to rip off that exponent. Well, I have to undo what that exponent is doing. Well, what's the reverse of squaring something? The reverse of squaring something is taking the square root of it. So this is the action that I want in order to make this guy go. So I'm just going to leave him here untouched. I'm going to take the square root of this side. Yeah, and oh, by the way, Whatever I do to one side, I have to do to the other. So it's going to be the square root of 32RF. So I got that square root guy going in both of them. All right, so now I'm going to solve this part. I'm going to simplify. This guy rips him off, leaving me with V. And over here, well, there really is something I can do with it, but for our purposes, we're not. So he gets to stay just the way he is. And I'm just, for the heck of it, I'm going to put it in multiple alphabetical order. You don't have to. Absolutely don't have to. Either way is fine. So here's my answer. And you know me, I like the variable on the left side. So I just switch sides. And so what I've done, I started out with this formula for cornering force, and I ended up generating a brand new formula for velocity. So let's take a look now at sample number 2. Put this over here. Move this up a little bit. So this guy here, this fella, is the formula that we're going to use for solving the octagonal window area formula in construction, whatever that is. So I'm going to start with this guy, and they want me to isolate the N. And again, I'm going to write that PEMDAS thing in reverse. PEM, and I can't remember what it is in reverse, so I better start here. SADMEP. So this is the guy I'm going to be using. So I start with him. Area is equal to 4.828 N squared. Okay, and I'm after N. Well, let's see. I don't have any subtraction or addition going on. Do I have any division or multiplication? You bet I do. Right in here. It's 4.828 times N squared. So I have to undo that. I have to break that. Undo what's being done. And in order to break that, I'm going to leave him alone, leave him nice and clean. I'm going to divide this side. It's the opposite of multiplication, and whatever I do to one side, I have to do to the other. 4.828. 4.828. Okay, these guys reduce down to 1, leaving me with N squared. I'm going to bring him down. 4.828. And now this is very much like the one that we just did. I have to get that guy gone, rip off that exponent. And how do I do that? I do the opposite of squaring, which is square root. And what I do to one side, I have to do to the other. And it's really, 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 really important that you put this square root sign, which is called a radical, this radical sign, over the whole enchilada. Don't, if you have this 4.828 and you take the square root, make sure that you don't put it just over the top, because that's not the same as this. So be real careful that you put the square root sign, nice big radical sign, over the whole thing. Okay, so we know what this is because that square root is undoing him, which is going to leave me with an N. And I can't really do anything over here, and whenever you can't do anything, you just kind of bring it down. 4.828, and once again, you know me, and this is a really good form I'd like you to develop. So it's A over 4.828. And hopefully I didn't make any mistakes. And we started with this formula, and we now have a new formula for finding N. Whatever that is, who knows? Maybe it's, I don't know, the length of one part of the octagon. Okay, let's take a look at the next one. Move this up. Okay. All right, so this formula here for the volume of a cylinder. Volume of a cylinder. Here's cylinder, so you have an idea what we're talking about. And volume of cylinder, you notice it's got this little guy in here called pi. Okay. And numerically, he's approximately equal to 3.14, but we really don't care for our purposes. And volume is three-dimensional, like how much this can hold, if you will. And you'll notice that the formula is basically the formula of a circle, top, multiplied by the height. So that's kind of where the formula comes from. And they want me to go ahead and isolate h. So I'm going to solve for h. I'm going to start with the formula, r squared h. Okay, so I'm going for r. And let's again look at that PEMDAS thing. I got PEMDAS, sad DAS, PEM. I can't remember that. PEMDAS. So it's sad MEP. I'm gonna have to remember that. sad MEP. Okay, so there's no addition or subtraction. Nope. So I can't do anything there. But there certainly is no division. But there's a lot of multiplication. This guy is being multiplied. This guy is being multiplied. And what's really cool about this is I can knock out or undo all that multiplication all at one time. Remember, the opposite of multiplication is division. So if I want, in this case, the pi to go, because remember, I'm after the radius. If I want the pi to go and I want the h to go, that's what I'm going to divide by. And follow the rules for keeping equations balanced. What I do to one side, I have to do to the other. And as you can see, the pi is reduced down, the h is reduced down, leaving me with just r squared. And this guy, he stays the same. Okay. All right, well, again, this looks just like, one of the other ones before. So that exponent's got to go, the opposite of squaring, taking the square root. So I'll take the square root of that side and take the square root of this side. And when you do your work, don't be lazy about it. Give me a couple of extra steps so that you don't mess up your problem and I can see what's going on. So square root of r squared is equal to r. Again, that guy, nothing I can do with him. I'm going to leave him alone. And I'm going to take this guy, flip him around. R is equal to square root of v over pi times h. There you have it. All right, let's do problem number 5, example 5. Engine displacement. Everybody loves engine displacement, especially all you diesel and automotive guys. So we're going for S. And problems are getting a little bit more involved. That's okay. We're good. So we got displacement is equal to pi times b squared. B, I'm sure, stands for bore. Remember that. S is for the length of the stroke. C, I'm guessing, if I'm right, is the number of cylinders. And we got this number 4 down here. So I'm after him. So let's see if I can remember this. Sad MEP. And once again, any subtraction or addition going on? Nope. How about division and multiplication? You bet. I've got division going on, and I got some multiplication going on. And I don't like fractions. Remember, nobody likes fractions. So we're going to clear out that fraction. And we're going to undo the division. And the way you undo the division is by multiplication. And once again, I'm going to make this guy look like a fraction because he's a fraction. And what I do to one side, I've got to do to the other. So over here, I get a 4d. These guys drop out. And I end up with pi b squared SC. Now, who am I going for? I'm going for S. I'm going for this guy right here, right there. I should maybe put him in a different color. S. To remind myself. What am I going for? All right, so what's connected to the S? Well, I got a pi on there, I got a b squared on there, I got a c on there, and what are all these guys doing with this S? They're multiplying the S. And so in order to break the multiplication, to undo the multiplication, I'm going to do division. So there they are. And underneath, I'm going to write down all the guys I want to get rid of. So the pi's got to go, the b squared's got to go, and the c has got to go. And what I do to one side, I have to do to the other. Pi, b squared, and c. Boom, boom, boom. And these all really become ones, leaving me with just S. And this guy's going to come right down. I'm going to take him, flip him over, and I got a formula now for stroke. So if I'm looking for the stroke and I know the engine displacement, and I know the bore, and I know the number of cylinders, this formula is a lot easier to use to solve for stroke than me going back. Oh, kind of didn't see a lot of that stuff. Than me going back to the original formula. Okay, let's see what else we have in here. Got a few more. This next guy is for horsepower, so I'm going to kind of pick up the pace. I'm going for S, which I'm sure is speed here. So, got H is equal to W. You can see it's a little different. Got some parentheses going on here and an exponent out here. S over 234 to the third power. Okay. And again, SAD MEP. I don't have any addition or subtraction. Don't have any, and I'm going for S. I'm going to put a big S in there. S. Okay, I'm going for him. And I do have multiplication and division, and the multiplication and division that I have is right here. Now remember, there is exponents going on, but that comes later. I'm going to tackle this multiplication right here. So undo multiplication by doing division. So I'm going to write this carefully so it's clear for you. I'm going to divide by W. That's going to knock those guys out. And I'm going to knock those guys out and reduce them down to 1. And I end up with S over 234 cubed is equal to H over W. Ooh, cubed, not squared, cubed. Okay, now I got to rip him off. Well, what's the opposite of cubing something? The opposite of cubing something is taking the cube root. Whatever this is, that's what this is. So if I'm going to take the cube, this is really not equal to each other. These are opposite actions, okay? So this is going to rip him off. That little guy takes him off. So if I take the cube root of all of that, I have to do the same thing over here. Cube root. Okay, so when I take the cube root of him, ta-da, he rips him off. S over 234. And I can't do anything over here, so he just kind of stay there. Enjoy the ride. Okay, so what am I after? I'm after S. I'm almost there. Almost there. The only thing that's in the way is this guy right here. And what's he doing with the S? Well, he's dividing. What's the opposite of division? Multiplication. So I have S over 234 times 234. And I'm going to make it look like a fraction because he's a fraction. And what I do to this side, I have to do to the other. So I got 234 times cube root H over W. Okay. These guys reduce down, leaving me with just S. All right. Now, when I write this down, just be careful. Whenever you have just a number like this times some root, he stays out in front. He gets to be the leader. So he's got to stay just where he is. And I can take out that multiplication sign. No harm, no foul. And then we're going to take this guy and we're going to turn him over. So I have S is equal to 234 times the cube root of H over W. Brand new formula that comes from this fella up here. Brand new. Alrighty then. Speed of a car. We got, what, 2 more to go. Speed of a car. And we're going for big D here. What would be big D? I don't know. Displacement. Revolutions per minute, maybe. And gear ratio. I don't know. Doesn't really matter. We're just messing around with the variables. So I have S is equal to dr over 336G. And I got SAD MEP. Okay, any addition and subtraction? Nope. How about division and multiplication? Yep. And again, sometimes I lose sight of what variable I'm going for, so I'm going to put it in red there. He's the guy I'm after. So let's clear out that fraction. Don't like him. So I'm going to break that division by multiplication. So it's going to be times 336G. Make him look like a fraction. That's going to wipe out that whole denominator. And what I do on the right, I have to do on the left. 336G. And these guys go, leaving me with dr. And I'm going to push these guys together. Take that multiplication sign out. 336GS. All right, I'm almost there. I'm after D. He's the only guy that's in the way. So he's multiplying, opposite of multiplication. Division. And I want the R to go, so the R's gone. And what I do to this side, 336GS over R. These guys reduce down, leaving me with, I'm going to save a step here. This is going to end up being a D over here, right? And I can't do anything here. And you know how I like it on the left, so I'm going to do both at once. D is equal to 336GS. Save myself one step. So now I got a brand new formula based on the formula for speed of a car. And finally, we got one more. We have one more. Solve the piston speed formula for R. The piston speed formula. This one looks like it's going to be pretty easy. Look, there's no radicals in there. There are no exponents in there. So I'm going to have P is equal to SR over 6. I'm going for R. Well, let's clear out the fraction. And I'm going to have 6P is equal to SR. And I'm going to go ahead and include that step. And you can see these guys drop out. 6P is equal to SR. And again, whom I'm after? Whom I'm after? I'm after R. I'm after R. Okay. So if I'm after R, S has got to go. Oh, that's a P, not a 5. 6P. 6P over S is equal to SR over S. These guys drop out, leaving me with just R, which is what I want. R is equal to 6P over S. And I'm done. Nice and clear. Everything in a nice, well, except for that guy. Let's fix that. 6P. Nice top-down fashion. Anybody who picks up your work will know exactly what you're doing. All right, so there's your homework. So I hope that helped. And enjoy the day.